For the following problem, we want to find the vertex, x-intercepts, and y-intercept of the function f of x equals x squared minus 6x plus 5. We have two ways to go about finding the vertex. The first way is to use a formula that says the vertex is at the value negative b over 2a, comma, f of negative b over 2a. Meaning the x value of the vertex will be what you get when you take the negative b value and divide it by 2 times the a value here. And then once you get that x value, you plug it back into your function to get the y value. So if we go through that, negative b over 2a means that we have negative 6 divided by 2 times a is 1, that's our value in front of x squared, which gives us positive 6 over 2, or 3. And from here, we can take that 3 and plug it into our function to get our y value of the vertex. So f of 3 is equal to 3 squared minus 6 times 3 plus 5, which gives us 9 minus 18 plus 5, which simplifies to negative 9 plus 5 as we go left to right in our order of operations. And finally, negative 4. So the vertex, in this case, we'll label it here, is the point 3, comma, negative 4. And then from there, we can find our x and y intercepts by setting the equation equal to 0 to find the x-intercepts. An x-intercept is anywhere that you hit the x-axis, and that occurs when y is equal to 0. So when the equation is equal to 0, we will get our x-intercepts. And we could go about this a number of ways. We could complete the square and apply the square root method, but we could also use the quadratic formula. In this case, though, the easiest way to go about it is to just factor. X squared minus 6x plus 5 breaks up into x minus 5 times x minus 1. When you multiply all of this out, you get x squared minus 6x plus 5. And now if we set each of these factors equal to 0, then that leaves us with x is equal to 5 when we add 5 to each side, and x is equal to 1 when we add 1 to each side. So our x-intercepts are the points 5, 0 and 1, 0. Remember, these zeros are coming from the fact that we set the function equal to 0 in this step. And we'll go ahead and give these a little label. Now finally, from here, to find the y-intercept, all we have to do is plug 0 in for our x values, and that tells us when we will hit the y-axis, whenever x is equal to 0. So we get f of 0, which gives us 0 squared minus 6 times 0 plus 5, which leaves us with f of 0 equals 5. So our y-intercept in this case is the point 5, 0. we said the x value is 0, and the y value is what we just solved for. It is the point 0, 5. Okay, so this is all the information that we were looking for. The vertex, the y-intercept, and the x-intercepts. But this is only one of the ways that we can go about solving for all of this. The other way is by completing the square. And it might seem annoying to have to go through completing the square when you can just memorize this formula, but it does have its uses. So we'll go through that process. Starting back at the original problem, we have f of x equals x squared minus 6x plus 5. And to complete the square, we're going to check if our x squared has anything in front of it. It does not, so we can immediately go to the middle term. We divide the middle term by 2 and square the result. That gives us negative 3 squared, or positive 9. So to complete the square, we're going to take our function and we're going to add 9 to this x squared minus 6x. But remember, we had a plus 5 on the outside, so we have to copy that down. And now this is a totally different problem because we've added 9 to it. So in order to correct for the fact that we've added 9 to the problem, at the very end we have to subtract 9, as 9 minus 9 will give us 0. So we end up with f of x equals x squared minus 6x plus 9. That's going to simplify down to x minus 3 quantity squared. So remember, completing the square is all about taking this x squared minus 6x plus 9 that we just created and rewriting it as x minus 3 quantity squared. And on the outside, we have plus 5 minus 9. That gives us minus 4. Now that we've completed the square, this is in our vertex form. We call this the vertex form of a function. So the way it works is once you have it written like this simplified form with something raised to a second power, the vertex is equal to the opposite of what's in the parentheses with your x. So how there is a negative 3 in here, it's going to be a positive 3 for the vertex. And then whatever is on the outside will keep its sign. This negative 4 will stay negative 4. And we get that the vertex is 3 comma negative 4 again, just like we had with the other method. And from here, we can still solve for the x and y intercepts. So if we go to this x minus 3 squared minus 4, sorry, that's a typo, x minus 3 quantity squared minus 4, we have that this is equal to 0. That is when our x-intercepts will occur. Just like before when we solve for our x-intercepts, we set the equation equal to 0. We're doing the same thing here. We're setting this equation equal to 0. And this is just a rewritten form of what we originally started with. And to solve this, we'll add 4 to each side to get x minus 3 squared is equal to positive 4. And from here, if we take the square root of each side, we get x minus 3 equals plus or minus 2. And if we add 3 to each side, we get 3 plus or minus 2 So x equals 3 plus 2, which is 5, and 3 minus 2, which is 1. And with a quick check, we could prove that both of these are true by plugging them back into the original equation that we started with, this x squared minus 6x plus 5. So our x-intercepts are 5, 0, and 1, 0 again. And again, we will label them. Finally, for the y-intercept, to find it, it is the exact same process as last time. We could plug in 0 for our x value, and really we don't even have to do it for this equation. It will work out exactly the same as last time, just plugging it into this original problem that we started with, the x squared minus 6x plus 5. And when we do, we would still get the y-intercept is 0, 5. And those are the two ways that we can go about finding the vertex, x-intercepts, and y-intercept of a parabolic function.